At first glance, its trajectory seemed typical. A long arc around the Sun would send it back into the deep void. However, weeks later, things shifted unexpectedly. The numbers altered. Its trajectory, once steady, began to curve inward, ever so slightly, toward Earth. This change was too precise to overlook. When astronomers recalculated its orbit, the reality became evident. This object was no longer merely passing by, it was on a direct path to our planet. The announcement sent shockwaves throughout the scientific community. An interstellar body, moving faster than any known asteroid, was on its way. Throughout astronomical history, only two other interstellar objects, Oumuamua and Borisov, had been identified. Yet, this one was distinct. It wasn't just passing through, it was headed straight for us. What made this unsettling was the physics behind it. An object traveling at such high speeds shouldn't easily change its course. Gravity could deflect it slightly, yes, but to bend so neatly toward Earth demanded an explanation that remained elusive. Teams worldwide double-checked their instruments, recalculated gravitational impacts, and ran new simulations. Each time, the outcome was the same: *3i, Atlas was on a collision course. The implications were enormous. Given its predicted size and speed, even a close encounter could unleash energy far surpassing the most powerful nuclear explosions recorded. And if it collided directly with Earth, well, the consequences would be disastrous. The pressing question shifted from whether it would pass near to what exactly it was and what materials it contained. Observatories globally turned their focus on this incoming visitor. Space-based telescopes joined the effort, analyzing every wavelength of light it reflected. Its composition was peculiar, neither purely icy nor completely rocky. Brightness changes hinted at a tumbling, irregular shape. Certain readings suggested volatile gases, as if it were venting like a comet. Others indicated denser material, akin to an asteroid formed in a distant solar system. Nothing about it conformed neatly to recognized categories. However, the deeper mystery lay in its trajectory. If gravity alone couldn't account for the shift, could something else be at play? Some scientists proposed that jets of sublimating ice acted like tiny engines, subtly guiding it inward. Others suggested more exotic theories, that it might have traversed a region dense with dust or magnetic disturbances. A few cautiously contemplated whether the adjustment could be intentional. As time progressed, the world's focus turned skyward. What began as a scientific curiosity evolved into a global obsession. News channels aired live trajectory simulations. Social media overflowed with theories. Was it natural? Artificial? What might happen upon impact? Artists, writers, and filmmakers drew inspiration from the event, capturing the eerie beauty of a silent wanderer approaching Earth. Meanwhile, governments rushed to prepare. Emergency meetings took place across various agencies. Was there anything that could be done to deflect an object traveling at such velocity? Suggestions included kinetic impactors and nuclear diversion tactics, but time was tight. Missions that typically required years of planning now needed to be conceptualized within weeks. Space agencies examined every potential launch window, racing against time and the laws of physics. As it neared, collaboration among nations surged to unprecedented levels. Telescopes in Hawaii, Chile, Spain, and Australia synchronized to maintain constant observation of it. Data flowed continuously between observatories, refining trajectory models in real time. For the first time, humanity operated as a unified observing entity, one species staring into the void, connected by curiosity and concern. The models became increasingly accurate. The margin of error diminished. Then came the unwelcome realization no one wanted but everyone anticipated. Earth lay directly in its path. This confirmation altered everything. Instantly, global priorities rearranged. Countries that once competed in space exploration began sharing blueprints, resources, and data. Scientists and engineers collaborated across borders, not for recognition but for survival. For the first time in modern history, humanity confronted a challenge not rooted in politics or ideologies but simply existence. Yet, even amid potential disaster, hope remained. The notion that something originating from another star could reach us, could physically impact our world, was awe-inspiring. Regardless of the outcome, 3i Atlas would impart knowledge. Its visit would teach us about the galaxy, resilience, and the delicate yet extraordinary fabric of life on this planet. As the final days approached, the object brightened, becoming visible even to the naked eye from darker locations. People gathered on rooftops, beaches, and fields, witnessing the slow approach of a light that had traversed ages through emptiness. While many felt fear, others experienced a deeper emotion, a sense of connection. A feeling of belonging to a vast, living universe that retained the power to astonish us. In those moments, humanity felt both insignificant and infinite. We had gazed at the stars for centuries, wondering if they would ever gaze back. Now, one of them had done so. Whether 3i Atlas represented coincidence or intent, chaos or fate, it reminded us of something profound. We are not separate from the cosmos. We exist within it. And it can reach out to us just as we reach for it. Remember to subscribe to our channel. Thank you for watching.